Greetings, and welcome to an introductory lecture on threads. Now, something to keep in mind as you're starting your journey into learning how to use threads. They are evil. They are nightmarish. They will complicate your code by orders of magnitude and create weird and wild bugs that are a massive pain to try and track down. So you're probably wondering, well, if threads are so terrible, why would I ever want to use one? And the blunt answer is don't, unless you need the power. Let me demonstrate. Now, granted, I have a fairly high-end system, but it's not completely bonkers ridiculous. I have a 6-core processor with hyperthreading. That means I have 12 logical processors. That means I can have 12 threads running at any given time across my 6 cores. So if I want a program to be able to use the full power of my computer, it needs to have 12 threads. Even relatively inexpensive phones these days are going to be dual-core devices. I mean, if you want to murder the phone's battery and have the phone running at maximum speed, your code will have to be dual threads. You'll have to have 2 threads. Now, what exactly is a thread? Well, pretend for a moment that you have 3 tasks to do. You have to wash the windows, you have to cook a meal, and maybe mow a yard. Now, if it's just you, you represent a thread of execution, and you can do a task at a time. You can wash the windows, or you can work on food prep, or you can mow a yard, but you cannot do any of those simultaneously. You can do a task. Now, you can switch between them. You could, for example, wash a pane of glass or wash just a small section of the glass and then run over to the stove, check to make sure that nothing's burning, run outside, maybe do one pass with a lawnmower on the grass, run back inside, clean a window, and so on and so forth. This is what we call context switching, and it's what programs and operating systems would do before multi-cores were common in the consumer market to give the illusion of doing multiple things at once. The computer really wasn't. It was only ever thinking about one task at a time, but it was switching through those tasks fast enough that you couldn't tell. And just like the example I gave, there's some overhead, right? It's like if you're running between the kitchen and a window and the outside, there's obviously overhead associated in switching between those tasks. And in context switching, there's expenses, there's overhead and associated with switching tasks and threads on a single core CPU. But now imagine that you have 4 people living with you, roommates, family, whatever, it doesn't matter. There's 4 people living with you. Now you've got 4 threads that can be doing independent tasks. So you can have one thread or person cooking a meal, another thread washing windows, another thread mowing the yard, and then another thread sort of being the glue that keeps everything running, helps the cooking person grab things as needed, maybe swap out rags for the window cleaner, bring the gas can to the lawnmower person so they can keep mowing, etc. That would be an example of multi-threading. You've got multiple tasks being executed at the same time. Now, all of that's great and all, but it's very abstract. So I am going to use this little game here to visually demonstrate the power of threads and visually demonstrate, why I need to use threads in order to maximize utilization of a resource. The game in question, by the way, is The Farmer Was Replaced. Sadly, the language that it uses is Python, not Java, But still, if you're looking for a game that will also help you with your programming abilities, being able to think like a programmer and solve things with algorithms and such, I cannot recommend this game strongly enough. It is incredible. It is awesome. It is well worth the $10 or $15, can't quite remember which, that it cost to buy this. It is phenomenal. But for the demonstration, there's this resource called Power, and it makes your drones move fast. And in order to harvest power, you have to harvest sunflowers. And so what I could potentially do is I could plant a sunflower on this one square here, and then just wait for it to grow, and then harvest it. But that's really inefficient. It's like you can immediately look at that and tell this is a restart. This is a horrible way of doing things. Like just the whole aspect of waiting until that's ready to be harvested. It's like, yeah, my drone's just sitting there doing nothing. It is obviously very inefficient. So then the next logical step is well, I've got this entire row that I can plant. Why not plant the entire row, come back, wait until I can harvest this first flower, and then harvest the entire row? So again, to run that one more time, we've got the waiting for a single flower to grow versus I'm going to plant the whole row, maybe have to wait a little bit for that first one to finish maturing, and then harvest the whole row. Much more efficient. This is algorithm efficiency. And I am going to eventually hit a wall. Like, instead of just letting it run once, I could let it run in an endless loop. And then remember that I've got to uncomment from my earlier test runs. There we go. So now it's just going to run on an infinite loop, planting, harvesting, planting, harvesting. And there's more algorithmic efficiencies that we could implement here. For example, I could replant as soon as I harvest, so that way I'm not leaving a space blank like this. I could immediately be leaving that behind to grow. But again, there will eventually come a point in which I have written the absolute perfect algorithm to completely maximize my energy per second on this one singular column here. There's a hard limit as to what I can do. And it's also very visually apparent that I am not utilizing the full range of this area here. And there wouldn't be any point in like having the drone itself, just this one singular drone, plant everything. It's already mostly efficient to have it do one column. If we just had it move over and do a second column and just sort of alternate between harvesting this column and harvesting this column, it would be at 100% efficiency. You couldn't squeeze anything else out of it. So we need to thread this. We need to add in additional drones or threads so that way I can utilize more of my resource here, more of the farmland. But this is where threading becomes complicated. Let me comment out that. So we've got the flawed multi-threaded version first. And here I'm just simply very naively taking the existing single-threaded code and just trying to run it in 2 threads without any real thought or consideration. And what we end up with is basically one drone is going to get stuck on that first slot and basically not do anything. Both drones are stuck there, and now that drone moved, and this one drone is always going to be stuck on this spot. And that is the danger of multi-threaded code. You pretty much have to go in almost from the start, anticipating that I am going to thread this logic. Because logic that works perfectly fine single-threaded, like there's no errors with this code at all if I run it single-threaded, if I run it with a single drone. No issues whatsoever. But the moment that I try to move it into a multi-threaded environment, the moment I want to have multiple drones run it, I have to put in additional considerations or it's going to fail. And in this case, it's fairly simple. I can just simply have one drone move over to the side. So instead of trying to do 2 drones on one column, which doesn't really make too much sense, I now have 2 drones doing separate columns. But again, that did require me to put in a little bit of additional thought in making sure that I move that spot to actually be able to do the threading. And of course, the logical final conclusion of this is I spawn a drone for every column and have the entire board being utilized. Obviously, I am gathering way more energy per second doing it this way versus the old way of just simply having one column, or worse yet, algorithmically speaking, just simply using one square. Like, could I harvest 1,000 energy by just having a drone harvest a square like this? Yes. Yes, I could. But I would have to leave this program running for hours to accomplish that versus the, 10 to 15 seconds it's currently taking for me to gather 1,000 energy. So yeah, the combination of algorithm efficiency and threading to make sure that I'm fully utilizing my resource, my farmland, is what's getting me the maximum return. There's also other ways that threading can be very visually useful. For example, there is a maze, and I don't want to get into the details of this, but there's a treasure chest, and you have to reach the end in order to grab it. And once you grab the treasure chest, you can recreate the maze. And every time I create the maze, I'm always going to start in this lower left-hand corner here. The box could be as far away as you can possibly imagine, or it could be super close. And what we're seeing here is threading. Every time I come to a spot where there's a branch, I just spawn another thread and say, okay, new thread, you go down this branch. It's called a breadth first search. I am searching every possible path as I go down this maze. But again, I can do this, and it's efficient because of threading. If I try to do a breadth first search with just a single thread, this again would take orders of magnitude longer in order for this to work. So that's a visual example of why would we want to do threading. Now, the follow-up to this, now that you've got a general baseline introduction to the concept of threads, is there is a game developer's presentation that I have a recording of, an official recording, mind you, and I want you to go watch it. It's about an hour-ish long. Now, you are not going to pick up more than maybe 5 to 10% of the material that presentation is going to be covering. I have watched that presentation many, many times, and I still pick up nuances and additional meaning out of it when I watch it. It's a very high-level topic. But the demonstrations he gives, especially the visualizations of the wild, crazy, and unintuitive things that threads can do, of how the CPU, how modern CPU architectures actually work, That's the important part. So even if you're only walking away from this presentation with a 5 to 10% comprehension of what they were talking about, it is still going to serve you very well moving forward and trying to deal with threads. So just keep that in mind when watching this presentation. Do not try to multitask. Yes, I know it's an hour long. Grab a drink, grab a snack, sit down, watch it, give it your full attention, because that is the only way you will retain anything from this presentation. And then the following week, we'll actually get into how can we create threads in Java, and follow that up with, well, let's see how fast we can actually calculate every single prime from 0 to maxent, 2 billion and change. And with that, good luck with the GDC presentation, and I'll catch you on the next video.